The same typical interactions we find in design patterns also exist in functional programming. Those interactions are even more explicit in functional programming, and I plan to prove that in this video. I will start with a strategy design pattern and you will see what I mean. Look at this functional style function. It will transform the string, so it says. A corresponding concept in object-oriented programming is a method on an object. That is where the most canonical of all design patterns begins, the strategy pattern. A strategy is another object we would inject into an object or its method to modify its execution. The method that receives a strategy would support many different operations without even knowing the exact output it will produce. But what can we see in this picture? We first see the objects. There must be the object of this class, and there must be an object implementing the strategy interface. Still, the essence of the strategy pattern is in the interaction between methods. That is the most important aspect of object-oriented design patterns. The execution depends on the method borrowed from the other object. A pattern is not about objects, but about the method calls. I find great wisdom in that. Then comes the inflation of classes. One concrete class would turn the characters to uppercase, an entirely new class would turn the characters to lowercase, and so on. Why define so many classes if we only need a method call? Functional programming simplifies matters by a significant margin. The substance of every design pattern is in letting one method call another method with an implied meaning. Forget objects, request a function, a func delegate, and ditch all objects. A delegate is an object anyway. Call the delegate or pass it further on and everything will keep working as before. Forget about one-method interfaces and their concrete implementations. That has always been the greatest source of criticism against design patterns, that artificial need for more and more classes to complete the ceremony. Forget them all. Focus on calls between methods. Every design pattern boils down to choosing the right interaction among the methods. In functional programming, all such interactions are reduced to their bare essence, functions. You will never hear about the strategy pattern in functional code. Any higher-order function receives a strategy, so we speak of higher-order functions instead. A former interface becomes a delegate, a standalone function if you like. Passing it into a higher-order function is the signature concept of functional programming. I will spice it up just to show you how powerful higher-order functions can be. The delegate will accept the current character and the one that precedes it, and produce the new version of the current character. The implementation will be more powerful this time. First, extract the pairs of characters and their predecessors, using the null character instead of a non-existing one. Remove any null characters produced by the delegate. Join the results back into a string. This function can accomplish a lot if you know how to use it. Here is some input string. I will now inject several different character transforms into it. This call will turn the string to uppercase. A lambda takes the current character and returns its uppercase version, ignoring anything preceding it. That will systematically convert the entire string to uppercase. How about compacting multiple subsequent spaces? Ignore the current character if it is whitespace preceded by a whitespace. Otherwise, retain it. This lambda will reduce each stretch of whitespaces to a single-space character. I have spared the most complicated lambda for the end. The request is only to retain numbers and whitespace characters and remove everything else. A digit or whitespace stays. Everything else disappears from the output. Functional programming reduces boilerplate to a minimum while retaining strong typing and reuse. You can assign any lambda to a delegate object and reuse that object later. Function composition is another immense strength of functional programming. Retaining numbers and then compacting whitespace would admittedly be more verbose and more complicated with objects. It is just a chained call in functional code, though. Are you ready to see these functions in action? Here, every lambda has transformed the string in its own way. The first string is in uppercase, the second one is compacted, and the last string only consists of numbers separated by a single space. This completes the most important lesson about design patterns you will ever learn. 2 lessons, in fact. One which I haven't covered in this video is that you can reduce any design pattern to a strategy pattern. The second important lesson you see on this screen. It shows that the strategy design pattern is the business between 2 functions where one receives the other and uses it. Interfaces and objects are a necessity in an object-oriented design, but even then you should prefer injecting functions rather than interfaces for the sheer simplicity of code you will end up with. Let me give you another example, the specification design pattern. You can download the source code for this video from my Patreon page. That code includes these 2 patterns and a few more that I will not demonstrate in the video. Please remember that every registered patron is helping hundreds of other fellow programmers watch all the videos on my channel for free. Now a word about the specification pattern. It is just a function returning a Boolean value telling whether the object it received satisfies the specification or not. I repeat, a specification is just a function. The pattern is in how we perceive that function. This delegate models a password policy. Concrete specifications are just functions assignable to this delegate. One would test whether the password is at least this many characters long. It is a function returning a function. I'm returning a lambda that captures the minimum length in its closure. It compares the actual password length against that value. Other concrete specifications would look for an uppercase letter, a lowercase letter, or a digit. Finally, one more concrete specification would request a special character from the list supplied. We would define an interface and a bunch of classes in an object-oriented code, but that is only to satisfy the norm. I advise you to stick to delegates in C# and focus on the essence, a Boolean function. You will lose nothing but a ton of code you never wanted to type anyway. There is one essential part of the specification design pattern that I must add here. It is mandatory to define operators such as AND, OR, and sometimes NOT that combine multiple simple specifications. The implementation is obvious, of course. These operators let you combine atomic specifications into larger ones, giving the specification pattern its true power. It is common to combine the specification pattern with the null object pattern. A null object in functional code is just a function that does nothing. Think of that next time when you derive a class in C# to implement a null object. The composite pattern can also give richer semantics to the AND operator on specifications. Look how beautifully simple it is. Using a specification would even bring the strategy pattern back to the table. Of course, it is only a higher order function in functional code. This screen shows all the power of functional programming. There are 4 design patterns here, and yet each of them is just a function with no ceremony around it. These are the sample passwords I plan to test against the strategy. Only retain the passwords that satisfy the policy. Print them out. Keep in mind that applying a design pattern should lead to trivial code on the consuming end. If the calling code is complex, you did something wrong. I will now test several password policies built out of those simple ones. No constraint is the first one, followed by the minimum length constraint. Then come the more stringent ones, requesting a capital letter plus a digit, and then both plus a special character. What shall it be? You can see how the list of valid passwords gets shorter and shorter as we add more policies to the specification. Combining specifications with the AND operator seems to work fine. Yet, it is only a function. That will not surprise you if you are accustomed to writing functional code. Virtually every design pattern of object-oriented programming is just a function with a specific signature and meaning in functional programming. If you are a patron, then you can see how I implemented a few other design patterns in the final code: composite, iterator, and even the chain of responsibility. Every single one of them is just a delegate and a function assignable to it.